Good evening, good afternoon, good whatever time it is with you when you are watching this. This is my weekly live stream of doing some Node-RED development work. I'm Nick O'Leary, the project lead of Node-RED, here with, like I say, an hour or so of some Node-RED core development work that hopefully you find interesting. Hopefully you follow along. Do say hi in the chat if this is your first time. If it's not your first time, see the guys already saying hi. Jibbob Scolci, Softy2K, Mauricio, Nathaniel, everyone's here. Excellent. So, what is the plan for tonight? What's going on? What's going on in the world? So we've got a new Node-RED fix release tomorrow, 1.3.4. We seem to be doing fix release Tuesdays at the moment, which you never know, could catch on. But that's pretty much all ready to ship tomorrow. What we're doing tonight is a look at, so there's a bunch of stuff I'm doing for 2.0 where we want to try and get the beta for that done this week. And in doing some of that work, I've uncovered a potential bug in some existing code around the hooks API, which I know I've spent plenty of time on previous streams. And having identified a fix, or the rough shape of a fix, I thought I actually held back earlier from just getting on implementing it, because I thought, nope, this will be a fun exercise to do on the stream, because it's not too complicated, and yeah, should make for an interesting hour or so. So what's the issue? Now, having said all that, I don't know if I've got a good... Let's see if I can find all the right pieces. Right. I've actually fixed my script so that my script that auto lays out all my windows ready for the stream now works and puts everything in the right place, which means I spend far less time faffing trying to find all the right things. Right now I'm faffing just trying to find the right window to show you what's what. What do we want? We want Atom, so I can show you code. So I have started, let me think through, what do I want to describe? Because I don't want to get too bogged down into the how I stumbled across this issue. It's more about what the issue is. So it's all about the hooks API. So if you remember, and I know I've shown this quite frequently on this stream, I'm sure if I just, the plugable mess routing, we have the hooks API that lets you insert custom bits of code. Let's find the API. Hooks.add the name of a hook and a function, and you get to remove it. And so that allows you to insert custom bits of code at various points here in the messaging path, more recently adding it into the npm install path, and that's all good. Now for a completely unrelated use, I thought, right, let's start play around with the hooks and try them out and actually build something using them. And just to try it out, I had a hook on send. So every time a message got sent, it would trigger that hook. And after some random number of sends, it would then remove the hook, because I wanted to show that the hooks could be properly dynamically added and removed, and it hit an error. So first up, I'm just going to show you the error. In fact, we're just going to, rather than try and describe it, let's step through this. So I'm just going to borrow the inject node because it's just convenient place just to throw in some code, and we're going to add a hook on send. Okay, and we're going to call this my test hook. So this is one of the things with the API. If you want to be able to remove a hook, you have to provide an ID like this, where it's the name of the hook, dot, and then a label for this hook. And so it gets called send events, and that's fine. So what we're just going to do, say a console.log send events. And what we're going to have here is count equals nor count. So increment count every time this hook gets triggered, and say if count equals 4, then we do red.hooks.remove onSend.testHook. Okay, so hopefully that kind of makes sense. So we add a hook on this event. Once that's been called 4 times, i.e. we've triggered 4 send events, we then remove the hooks we don't want to do anymore. Right, let's see what happens. So I'm just going to run npm install because a bunch of the stuff I've been doing today, I've been adding and removing modules in different branches for different reasons, and I can't remember it. So it means at the moment, every time I switch branch, I have to run npm install just to get the modules back in sync. And I can't remember if I did that earlier when I set this up. And then we just run node-red. Dum-da-dum. Okay, so that's now running. What I might do is make the window a bit make everything a bit bigger, and we will pull up Chrome. If I just make this window a bit smaller so you can see the terminal below. Let's go to localhost. I forgot I had admin north set up for some other testing I was doing. Yes, go away, you lot. So let's just trigger. So I triggered the inject node, and you can see we've got a whole bunch of we've got one send event there. Oh, why is it? One sec, I'm just slightly confused about why it's printed out twice. Oh, okay. This is going to confuse matters. It's printed out twice because I've got some other code. The project I was working on, unrelated, is still installed and it's still running and it's still printing out. So, not to worry. We're going to see some extra output, but we should still see the error. So if I'm just injecting a few times here, cannot read property CB of undefined. Now, you have to take my word for it. That has happened on the same iteration that we've called this remove on. Okay? Which is unexpected. We should be able to remove the hook and have it just work. Let me just... phone pocket buzzing. No, we're all good. So we are getting this error unexpectedly when we try removing the hook. So what's going on? Now, that was a good noise. It is a slightly pathological case where a hook removes itself, a hook removes itself whilst it's being run. Now, that's entirely valid. Someone might add a hook that should only get evaluated once and wants to dynamically remove itself. So it's a perfectly valid thing to happen. So what we want to have a quick look at is, so if you recall, cannot read property CB of undefined. Well, CB is this thing here. And here we're inside the call that deals with invoking one of the triggers. So Node-RED core code has said, please trigger hook with this ID, with this payload, and call this as the function to call once you've finished. So the first thing we do is, in hooks, we've got this object called hooks, keyed by the ID, and that gives us back an array of all the functions that are registered for that hook. And then with some boilerplate stuff going on here, dealing with the fact it can be, if you don't call trigger with done, then we will return a promise. Otherwise, we will invoke the stack with the callback and do it the callback style. So at this point, invoke stack is called, where hook stack is the array of callbacks we're going to be making. And we've got this test here saying, well, we start a counter at 0. We've got a couple of inner functions, but we set the counter to 0 and then we call next hook, which is this inner function here. We check to see, is I, our current counter, equal to the length of our hook stack, i.e. it's got to the end, in which case we can return. Otherwise, increment the counter and get the hook. And herein lies the bug. Because if, when we invoke the hook later on, it removes hooks, this hook stack array is now shorter. It's modified the length of that array. So let's say we've got two things in the array. Oh no, okay. Let's use the example we've got. We've got two things in hook stack, the hook stack array, and I is equal, and we're on the second one. So I equals 1 at this point, because we've done the first pass of it 0, next pass it's 1. It will get invoked, and then it comes back in here and it says, right, it's not equal to the length, because the length is 2, so it carries on. But the problem comes because if the hook reduces the length of hook stack, length is now 1 and I is 1, but I gets incremented, so I's been incremented to 2. So I has gone past the end of the array. So the very trivial fix would be to say, if I is greater than or equal to hook stack length, then that will handle the case where the hook stack shrinks. So Node is restarted there, so we can prove that to ourselves. If I just keep hitting inject, you can see it saying disabling again. That's my other experiment that I won't show you at the moment. But actually that's quite handy because you can see no more messages are coming out. And that's because both my experiment and the inject no code I have added have both removed themselves cleanly. So on the face of it, that could be it. That could be the net result of doing this fix. But there's a slightly more elegant approach, which I was going to spend some time on engineering, which is rather than, perhaps a more elegant approach that will provide, I think, a bit more resilience to hooks that are dynamically added and removed. Now, there's something to be said that am I trying to prematurely optimize, or I'm trying to fix bugs that, frankly, probably aren't ever going to get hit? Well, maybe, but I'd much rather address this now I've noticed it and then not have to worry about it again. So, the basic idea I had was, well, what if we change, rather than have an array, treat these stacks as a linked list? So each element just knows who the next element in the list is. So if when we come to remove an item from the stack, then it will still be hold on. See, this is where I think I've just spotted a problem with the linked list approach that I didn't. Anyway, let's do one thing at a time. This is the problem I was going to spend some time on. Does it make sense to re-implement the internal of the hooks data structure as a linked list rather than just a flat array that we iterate over? Now, with all good tests or all good bits of engineering, we're going to start with a failing test case. So I'm just going to revert that revert that fix I did, and we are going to try and figure out what's the best way to test this. We are going to just remember how we've got this stuff all set up. Right. Lots of tests for all the error handling. This is a test around removing itself. So here are the remove tests. So we're going to write a test case and say it can remove itself whilst being called. Well, it allows a hook to remove itself whilst being called. I think that makes sense. Right. And what is the test? Well, first up we need to set up our hook. So we're going to add, and just by convention, you can see I label these tests. Well, I have to use one of the valid hook IDs, so I just pretend I use onSend because it's one of the valid ones. And what we're going to do is pretty much exactly the code I had is all of that. That makes sense, doesn't it? So we add a hook on the onSend event labeled A. Its callback will just remove itself. Yep, all good. And then we want to do a hooks.trigger onSend with data. Does it matter what data is? No, we're just don't really care what the data is. And then the callback. And then I think we should say should not exist because we don't want to have an error. Yeah, I think this makes sense. So let's just try catch this. So I think this test will currently fail because that's a close recreation of the scenario. So let's run the test case. Mocker test unit at node-red. Where are we? We are in utils. We moved it. Util hook spec. And there you can see an error. Allows hook has failed, and so cannot read property CB of undefined. Exactly the error case we had before. Good. So again, we can just make that one line change, and the test now passes. Okay, but now we've got a test for this scenario. Let's see about what does it make sense to re-implement this as a linked list. In fact, before we do that, there's another test I want to do. In that, let's create hooks.add going to say add some more hooks, because we want to say in fact, I'm just going to copy from down here. So this hook, what we're going to have is the data we're going to inject is this object with an order array. And each hook is just going to append itself, if it gets invoked, it's just going to push its identifier onto that array. Well, in fact, only A and C are, because B is going to remove itself. So, and then we make sure we pass data in. So what we're saying here is error should not exist, and data.order should equal, well, A should definitely have been called, and C should definitely have been called, and we're not going to worry about B. Let's see, does that test pass? No, that test still fails. But is that because I reverted that fix? No. Okay, so in fact, now this is really good. So let me just step through this. So we add a hook called A that will push the character A into our array. Then B, which will remove itself, and then C that will push itself onto the array. So when we trigger, we expect A to be triggered and payload order to get pushed on. We expect B to be triggered, which will remove itself, and we expect C to be triggered, which will push C into the array. So I hope you can see, we expect the outcome to have A and C in the array. And when we run it, it's telling us, well, no, we're only getting A, we're not getting A and C. So actually, this I is greater than or equal to the hook stack length is not a good fix, because it ends up skipping the hook after the one that removed itself. I think it's just that one. So just to confirm, if we were to add D as well, so now we would expect A, C and D, and now we run, I predict we'll get A and D. Yep, so we get A and D, it's missed off C. Okay, well this is good actually, this is better than I was hoping. So this is a real bug. So now we can either go down the linked list approach, I don't know if that's going to be the right answer here, or we think about, well, what else could we do? Now, the key thing in all of this is we have to be efficient. This code gets triggered multiple times for every message being sent. So it has to be quick and efficient in doing what it does. And we can't spend a lot of time trying to figure out what it should be doing. Yeah, the code can't be computationally expensive. It has to be efficient. So one simple solution potentially would be to clone this array. So basically take a snapshot of it, and which is then immune from any modification of the hooks stack by the hook itself. So once the onsend is starting to be processed, it's going to trigger all of its hooks at that point in time. Even if one gets removed midway through, it's still going to process that whole list. Now, that would certainly fix it because it would stop things getting modified. The downside is that's going to be computationally expensive to take a clone of that array every time a message flows through. So it'd be nice to try and find an approach that is a bit more immune to some form of data structure that allows it to be modified, but preserves the right order of things. And this is why I think a linked list could well be the way to go. So how is that going to work? Let's see, have I got... Let me just check. Well, I have got the whiteboard. Let's see, have I got the... Let me find... I haven't used the whiteboard for a while, so... Hopefully, if I pick the right colour, this should start coming through. Cool. So what we're going to have is... let me just find the boundary of the screen. There we are. At the moment, we have our... Has that worked? Nope, that did not work. Pencil. There we are. So we've got our array of these. They're objects with including the function pointer. Oh, I haven't got my graphics tablet out, so this is slightly painful to do. Yeah, a bit of a scrawl, but you get the idea. So then what happens is, because we just work our way down the list, this is index 0, 1, 2. What we see, if this is, in fact, let's match it to our test, A, B, okay, I've forgotten D, but we've got A, B and C. Oh, that green is a bit contrasty, but hopefully you can see what I'm drawing. If B removes itself, C becomes index 1. And when we're iterating over the loop, we then moved index 2 where C was, but C is no longer there. So what might be a better approach is... there must be a way to... Is there a way to... What happens if I... No. Oh man, this is going all over the place. Is there no way just to clear the whole page? Because if I reload it... Yeah, it's persistent, isn't it? This is... Oh, if we make this super big... Super big arrays... Oh, there... No. I've literally got to click on everything to clear it. Oh, man. And that's not... Oh, this is comical. Opacity... Erase... See... Just let me erase the whole drawing. Oh, bored of this. Right. Let's get back on topic. What we're going to have is, rather than an array, what we'll do is we'll create an object which has a pointer to the function, or reference to the function, and then a next pointer which will point to the next callback in the chain, and then point to the next, and so on and so forth. So then if, say, so if this is A, B, almost there, C, if B removes itself, then that's no worries, because the code, this reference to the next one in the chain will still be good. So it can go there. It will still exist in memory. We can still call it. So, does that make sense? Was that overly painful to watch me scroll that out? Oh, look, you can see the URL for that there. Oh well. Let's look at how we build this. So first we need to look at, well, three things. We need to look at how we add hooks, how we remove hooks, and how we iterate over them, because that's what we're changing. At the moment, the hooks code has this object, which is a hook ID to array reference. And we also have this labeled hooks, which lets us, the named hooks, the .a, .b, .c, those are the labeled hooks. And that lets us quickly reference, if you specify a label, sort of back reference to which hooks those are. So here is when if for a given trigger hook ID, we initialize it to an array. In fact, that's not what we want. What we want is, because we always need to append to the end of the list, this is now going to be hooks by ID, map ID to head of list, and this going to add map ID to tail of list. It's been a long time since I've built a linked list data structure, so I'm probably going to screw this up along the way. And again, we don't need to keep track of the tails. Is this just unnecessary? Yeah, okay. Let's not over-engineer this, right? So what we want to be able to do is say let tail equal hooks ID. If tail is undefined, so this is the very first one. In fact, one thing at a time. Let's create the list item. Call it hook item, and we're going to say it's got a callback function, the location of where in the code base register this hook for logging, and then have a next hook and set that to null. So that's the item. So now we need to append this to our list. So we say that the tail item is whatever the hook's ID points at, which to begin with will be the head of the list. If that's undefined, this is the very first one we're adding, so we can just set it straight there. Else, so if tail item is not undefined, then what we want to do is do a while loop of while tail.nextHook is not equal to null, tail equals tail.nextHook. So this basically will traverse down the linked list until tail does equal the end of the list. And in fact, what we'll say is we'll just rearrange this code to save repeating ourselves. We'll say if the tail, in fact, tail item, I should call it the right name. If that exists, then we're gonna. No, sorry. I was right to have this special case in. Let me fix that. Go back to where we were. Right. I just need to fix that name. So if the tail item is undefined, then we set hooks ID to the hook item. Otherwise, again, I've got the variable name wrong. If it's undefined, it's the first ever element, so we just set it straight there. Else, we traverse down the list all the way, so up until the point that tail item's next hook is null, because it doesn't exist yet. And we'll say that tail item dot next hook equals hook item. Cool. And that's all we need. We'll come back to this states.id because I think we can dispense with that. Okay, so that's adding the hook. Removing the hook is going to require a bit more work. And I'm just wondering, should they be doubly linked lists? Should I have references going both ways? Might do. Right, removing a hook, you can only remove labelled hooks. You can't say just remove on send because, well, you just can't. That wouldn't be polite. So this goes and gets removal hooks for this label. Labelled hooks gives us that quick and easy way to, if someone says star, so remove all hooks for the widget library. This can go look all of those hooks up and then remove them. Now, okay, so that relies us being able to do the reverse lookup from labelled hooks back into our linked list. To do that, we need to make sure these hook items are in labelled hooks. So we're going to move this code in our add function. So if it's a labelled hook, in fact, I'm not going to move all that code down because we need this error check to prevent someone adding the same label twice. We need to do that before we do any work down here. But now we get down here, we're going to take a record of the hook item for that. So rather than just, before I was just storing the callback, now we store the whole hook item because it's a linked list and we need that item to have the reference to the list to repair the list. And then what all this code is doing is going through and removing. It's going to go and pass that hook item object to our remove hook, which is this guy. And you'll see here what it was currently doing was it was scanning the array looking for a hook with a matching callback. And if it found it, it would splice it from the array and tidy up the other bits. Well, now it's a linked list. We need to do a different bit of work. In fact, we are going to make this a doubly linked list. So previous hook and next hook. And so because it's going to be doubly linked, we need to, at the point where we decide, here we are, so we're adding to the end, to the tail item, then we can say that the hook item previous hook equals the tail item. So that's going to create the references going in both directions. So when we come down to remove hook, and it's no longer just the callback, it's the hook item, rename the variable so we keep track of it. So how do we remove an item from a linked list? Well, this is nice because we no longer have to, I mean, this is silly. I'm kind of removing from a linked list is so much more efficient than removing from an array, because you don't have to scan the whole array. You can just, if it's a doubly linked list, you can just remove the item and repair the references of the items either side to skip over you. Now, the reason this is an optimization we don't strictly need at all is there's rarely going to be more than one hook. But again, it doesn't really cost anything to do this, and it's a fun exercise in implementing it this way. But also, I think for the integrity of hooks that remove themselves, the original issue, it is worthwhile. I think. We'll see. Anyway, so to remove a hook, so we have hook item. So let's say let previous item is hook item dot previous. I think I called it previous hook, didn't I? Yes, previous hook and next hook. And next item is hook item dot next hook. Right. So what do we need to do? We need to say if previous item exists, then previous item dot next hook equals next item. If next item exists, next item dot previous hook equals previous item. And that's it. That's removed. That's removed it from the doubly linked list. So we can actually remove a lot of this code, except for these dudes. So there is the one case where if previous item doesn't exist and next item doesn't exist, then that means we've just removed the last item in the list. In which case, we're going to delete hook's ID and we'll delete state's ID, because that's how we get back to sort of the null state of all of this. Okay. So we've dealt with adding, we've dealt with removing. We haven't dealt with triggering yet, and I don't think the tests... I think the tests rely on trigger working in order to validate that the add and remove have worked. So we're not in a position to start running the tests to validate what we've done so far. We've got to kind of get all the way through this. So at the moment we grab the hook stack. Now what we're going to do is, rather than const, because we're going to be changing it, hook item is hook ID. So if that doesn't exist, then we can return, break out straight away. Yep. Then just need to. So now instead of a hook stack, we're going to be passing in invoke hook item. Hook item, yep. And then that comes down in here. And now we no longer need this counter I, because we're not counting our way through. What we can say is if hook item dot next hook doesn't exist, so if not that, then there's nothing else to do. We can return. Otherwise, hook is hook item we need to change some logic here. So at the moment we're doing this test up front, but if I was about to say hook item, hook is, I was about to write that. Well, that would be wrong, because that means we would never invoke the first hook item. So in fact, what we need to do is when we, is that right? Let me just, yeah, call next hook. The first thing it needs to do is actually invoke the hook we've got. Yeah, so let's not worry about breaking out then. We're going to say call next hook, and that is going to be hook item. So everywhere I've got hook, I need hook item instead. All this logic is sound. Then, yeah, so it invokes it, and then it re-enters itself. Call next hook. Okay, and then, but how do we break now? Because so I removed that bit of logic, which is the thing that decides we're at the end of the list. We can break. Problem is, there are actually now multiple places where you know what, I'm going to undo some of this because I think I've deleted something I shouldn't have deleted. Yeah, I deleted that or error. So we need that. That's quite critical because that's how the error gets yeah, that we have to do it like that. Yes, this is the fun bit. Here you can see I do the I++, which means we get the current one and then we increment I. So next time round, by the time we come up here, I is already pointed at the next thing, which is why that logic works. But we're going to say oh, how best to do excuse me. I just don't really want to add some logic in multiple places down here to decide should we iterate again or not. Bear with me. That's where I go quiet as I try and play a few chess moves ahead of what I'm saying to give some sense that I know what I'm doing. Where do we call? So we'll call next hook there if there's an error. So that's right, we'll error out. So here we can say if yeah, if hook item dot next oh no, of course, sorry, right. Bit easier than I thought. So if not hook item, so if the hook item is not defined or there's an error, then we bail. And then just before we iterate, we can just say hook item. Yeah, I'm going to get rid of this hook reference because it just confused matters. Hook And yeah, hook item is the next item and then iterate. And that call next hook will have an error argument, so it doesn't matter, we don't increment it. And there's another one down here. There we go to the next item in the list and then re-invoke it, and that's good. And then that's the very first one where we don't. Okay. Good, good. Well, if you followed any of that, well done. But let's run the tests. And lots of tests fail. So what have I mucked up? I've mucked up lots. Okay. So start at the top. This test calls hooks in the order they are registered. Expected array A to equal AB. So, okay, I think this shows I was kind of secretly hoping it would work first time, but of course not. 934. Okay, so we add onsen, we add 2 hooks. Well, that's possibly curious that they're not labeled, but the point is, yeah. But you can see we expect A then B, but we are only getting A. So that does tell us there's a bug in our invoking. So let's put in some debug. Console.log invoke. No, we're gonna does that make sense? Right. We're also going to add -b to the mocker so it fails on the first fail. So we're just looking at one at a time. And what are we looking at? So we're asking to invoke this stack. And this is our linked list. So you can see this is the element. And you can see exactly the line of code from our test case that it got registered, which is nice to see that working. And the next hook is pointed to something valid, so that's nice. So I'm going to just have a look at what does call next hook get called with. So we expect it to get invoked twice. Call next hook gets invoked once, and then it gets invoked with undefined. Okay. So how's it getting invoked? Oh, because I wrote next item, not next hook. That will do it. If I don't use the right variable name. I'm tempted to rename those to just next and previous, but in fact, before I run that again, I'm going to take out those console.logs because let's just keep it quieter, and then with -b. Okay, so that's a few more passing. So now we're failing on a remove. Fair enough. So expected array AB to equal just B. So let's go look at that test case. Line 77. Oh, it does lots. So ignore the has's. So here you can see it adds A, then it adds B, then it removes A. So we should be left with a linked list of just B. So when it invokes it, it should just get B. But you can see here it's getting A and B. So there's a bug in our remove code. Let's go look at that. So what have I missed? So we get the previous and next. If previous item, we set its... Right, I'm going to standardize. I'm going to... Let's... Previous hook, previous hook, previous hook, previous hook. Next hook. stop getting mixed up between items and hooks. So we're saying if the previous hook exists, make sure its next hook now points to our next hook. And if the next hook exists, okay. Yes, okay, that's the edge case. If a previous hook doesn't exist, we are at the head of the list, which means we need to update our reference to the head of the list to be the next hook. Yeah, I'll do it. Run the tests, and the tests will pass. Cool. So that's nice. And what's also nice is you'll note the new test we added, A, B, C, D, we are now getting A, C, D. So it's properly fixed all of the bugs. Yeah. Now, I can think of some other nasty edge cases, which I suspect, as it's now 9 o'clock, is beyond the scope of what we're going to worry about tonight. But allows a hook to remove itself and others. Dun dun dun, what's being called. So what if not only do we remove all of B, but we also remove all of C? What's the expected result? Because if we remove the C hook, we wouldn't expect it to get invoked, because it hasn't been invoked yet. Now let's run. I think that's going to fail. Yep. So we got ACD, but we only expected AD. So even though we've removed C, it's still getting invoked. And yeah, I mean, that is entirely to be expected. Ooh, there's OBS. If I just go back to our whiteboard and find the... Yeah, so if you bear with my ham-fisted drawing a little longer, I squeeze in a D here. Then, doesn't help, right. The execution is in B. B removes B and C, so the linked list now, I'm not going to faff with the colours because I can't bother to keep switching. The linked list is now correctly looking like A pointing to D. So for any new invocation of the trigger, it will get A then D, and B and C won't exist. But because we're still in B, it's removed itself, but the object we're evaluating still has its next reference to be C. Is that true? Is that true? Right, let's just colour some links. So that's where we start. That's step 1. This middle row, A, B, C, D. When we remove B within B's function, the linked list will get repaired to look like this. And remember, these are all doubly linked chains. So that's the state of the linked list after the call to remove B. And then after the call to remove C, hold on, when we remove B, B still points back to that guy and forward to C, because we don't update the references of the item we're removing, we just update the ones either side. And C, I mean, that's a proper double link. And then if I go to a third colour, which, does that show up? Oh, just about. Let's try. Yeah, that shows up. When we remove C, it goes to its previous link, and that becomes a proper double link. But C's previous still points back to A, and its next still points to D. So B, in the current stack invocation, B looks at its next item, which will be C, and then yeah, no, it's kind of at that point where I think if anyone ever actually needs to do this, then I mean, they can do more than they could an hour ago with the array logic we had in there. So this linked list is better, and I think it's going to be the more likely scenario is well, I'm just saying it's going to be highly unlikely that one hook is going to have two different callbacks registered on the same hook, and it wants to remove yeah. I don't know if I'm sorry if I've lost you. I've sort of tried sort of jumped around a bit there, but yeah, I'm remove C then create C. Is that what's happening in the chat? No, I think what we've got is okay. It sort of preserves the integrity of the list of hooks. That I think it's reasonable to say that for a given invocation of a hook, any changes to the registered hooks whilst processing that hook could lead to unpredictable results. Now, is that good enough or not? No, it's not good enough. It's not good enough. Right, let's go back to this test case. So where we move both B and C, so we expect only A and D to get invoked. What we're going to do is, what we can do, when we remove a hook, we can set a flag on it to say it's been removed. Hook item.removed is true. Okay. Then down here, when we do the invoke stack and we go to next hook, we can add next check here. If hook item.removed, hook item equals hook item.next hook, call next hook. So Yeah, see, Jimbo, that's what I was trying to think through. What are the right checks to look at? Trouble is, I think if we say that once a hook's been removed, it should not be invoked, then by flagging it's been removed, then we can skip over it, but maintain the integrity of the list that was there before. So that the unit test now passed. We are now able to. We will only evaluate a hook. Well, sorry, we won't. By making this test, we won't now invoke a hook that has been removed, even if it was removed whilst we were in the middle of processing this stack. We'll skip straight over it, and I think that preserves the integrity. Yes. Yeah, I'm happy with this. It's 9:10. The unit tests are passing, plus some extra tests that we didn't have when I started, which is goodness. Let's just go back to the actual where I started with the inject node and its simple test case for this. And again, as before, you're going to see lots of debug. Being spat out. 3, 4. Yeah. And if you weren't here at the start, the fact it says disabling there and then I've received no more means it has cleanly removed itself and everything's still working. I haven't mucked up message passing. You can see debug messages in the sidebar are still flowing through quite freely. Everything's happy. Cool. So I'm going to say this is a job done. I'm going to revert the changes to the inject node because we don't want that. In fact, I'm just going to add a few notes in here for this is a doubly linked list of hooks by ID. Hooks ID points to head of list. Each list item looks like so what have we got? CB location previous hook next hook removed. The callback function. What else have we got? CB location. My file name line of code that added the hook. Previous hook. Reference to previous hook in list. Next hook, reference to next hook in list. Removed a flag that is set if the item was removed. Okay, so the only thing to think about, do we hold on to any references here that could leak? I don't think so. So the only place where we'll hold on to a reference is in the trigger function, but once that trigger and the invoke stack, but once they return, we don't hold any more references to a removed item. So yeah, let's add a bit more doc because it never hurts. Actually, no, I'm going to leave that now. It's getting late and it's getting late and I've had enough. Right, so rework hooks to rework hook structure to be a linked list. Allows for safe removal of hooks whilst they are being invoked. Cool. Grind. I'm just going to run all the unit tests just to make sure it is still working as designed, but all being well, I'll just let that churn in the background, and yeah, so that's quite satisfying. Yeah, all this hook stuff, I'm sort of itching to start writing plugins that take advantage of it. So you may have noticed the eagle-eyed. In fact, there, look, you can see unit tests have all passed in the core. So I'm going to push that up, and this is all part of the npm install hooks branch that I've been poking at, but that's all now ready to merge. I think we're happy with that. But yes, this has all been part of this new sidebar, the flow debugger, which is literally, that's all it is at the moment. It's a blank sidebar. But starting to think, I mean, this is not for 2.0. This will come after, but I kind of want to make sure there's a few bits and pieces I think the flow debugger might need that we would be better off getting into 2.0 before the final 2.0 release, so that the flow debugger will get published as its own npm module that you can just install into your Node-RED instance as long as you're on Node-RED 2.0. Yeah, so there we go. Fun times. The flow debugger is, I know I've said it multiple times, it's one of those features I've just been itching to make a start on. And yeah, whilst we've still got a long list of stuff for 2.0 to get done, it feels right to spend a bit of time, just like everything I've done this evening I wouldn't have discovered if I hadn't started playing with the flow debugger. So there's good value in doing that. Right, well, I'm going to sign off. It's 9:20 and it is time for a cup of tea. So thanks for joining. If you're watching on YouTube, please do leave a comment, say hi, do like, subscribe and all that good stuff. If you're in the chat, then thanks for joining. Thanks for keeping me company, and I will be back. I'll double check. It's a public holiday in the UK next Monday. May is great in the UK. You get 2 bank holidays, public holidays. The first Monday and the last Monday in the month are public holidays. So, yeah, keep an eye. I'll tweet if I'm not, but I'll keep you guessing. So have a good evening all, and I will speak to you soon. Cheers. Bye-bye.